Word optimization, we're finding optimal solutions. That means the best solutions, like the most economical solution. So our first example here, we've got the profit in manufacturing X kettles per day is given by this equation. So this equation tells you how much money you're going to make depending on how many kettles you manufacture. All right? So it isn't quadratic. And let's just talk about the graph of it, okay? Because it's a quadratic, it has a negative a value, which means it's going to be opening downwards, okay? And so then if we've got our graph here, it's going to look something like this. Along here we have the number of kettles, x, number of kettles. And on our y-axis, we've got the profit. So how much money you can make. And we're trying to find the optimal solution. We're saying, what's the most profit we can make? All right, because you might think, oh, just make as many kettles as you can, because then we're just going to make more money. But perhaps, like the point of the problem is, you know, maybe you make more than a certain amount of kettles, and you need to maintain your machines. Okay, and if you keep making kettles, then you're not maintaining your machines, and so then you need to pay money because your machines break down. All right, or something like that. So we're finding an optimal solution here. Now remember, for a quadratic, the vertex, the turning point, the maximum or minimum, they're all the same, occurs at x is minus b on 2a. So this is our process here. 1, develop the equation. Okay, that's going to be the hardest part. In our first example, it's given to us. Okay, just like with problem solving, we have to develop the equation. That's the trickiest part. Then the next part is just find the optimal solution using this formula. And then the third part is just to make sure that you answer the question.
In the problem, is it 564x?
Yeah, absolutely. Yep, there's an x there. Thank you. So, so we've got the equation. Step 1's complete. We're ready to crunch this. X is minus b on 2a. We're saying, what is the x coordinate of the vertex? And so we need to identify the values of a, b, and c. A is minus 3, b is 564, and c is minus 1200. So we need to include positive or negative in our dictation of a, b, c. So then when we put it into this formula, we're going to have minus 564 divided by 2 times minus 3. So we've got 564 minus 564 divided by minus 6. I think it's 94. We've got what we put in before. X is 94. Okay, so we're going to make the most profit when we make 94 kettles. The most profit okay, so that's, remember on the x-axis we've got kettles, on the y-axis we've got profit. The question says, how much profit are we making? How much profit are we making when we make 94 kettles? And so that means we want to know, well, x is 94 there. What is the corresponding y value? When we make 94 kettles, what is our profit? We're finding p of 94. We're going to put x is 94 into this equation. So we'll have minus 3 times 94 squared plus 564 times 94. Take 1200. All right, I've crunched that already. $25,308. All right, so when we make 94 kettles, we're going to make $25,308 profit. So all of this information that we've just solved here using this process though, you can just get from the graph. So I've gone into my graph menu and I've graphed this equation and I've had to zoom right out. Okay, so on my V window, I'll describe it to you. My V window is from 0 to 200, and for that's for X, and then for Y, I've gone from 0 to, what's an appropriate amount? 30,000. All right, and then that's when the graph looks like this, and I've just pressed G solve max, and it's given me those coordinates, 94 and 25,000, whatever it is. All right, so when we make 94 kettles, we're going to make that maximum profit. So you can, with a problem like this, you can get all your answers straight from the graph, but it's about demonstrating an understanding of this, the vertex formula, the axis of symmetry, and then we've input the value again, and then answering in the context of the problem as well. Okay, let's move on to the next one. Unless there's any questions. So we've got a chicken cage is erected against a wall. All right, so year 9 mathematics chicken cage problem. Remember that one, Sam? Yeah. So let's draw an example of it. Okay, here's a wall, and then we've got a chicken cage, and it's going to be rectangular. I know that wasn't dictated, I should write that in there. Rectangular or square. We're not going to have a semicircle or anything like that. We're not going to investigate that. And we've got 30 metres of fencing. Okay, so we need to come up with an expression to describe this being equal to 30 metres. So it's pretty similar to some of that problem solving we did, where we said we've got a limited amount of fencing and we need the total perimeter to add up to 30. So what we're going to do here is we're going to call both of these x, and then this length here is going to be 30 take away 2x. Alright, because then if you add up all the side lengths of this rectangle, x plus 30 take 2x plus x, you're just left with that 30 metres. Okay, so that's how we're going to do this one. So then the area of this rectangle, okay, the area of this shape, or A of x, the area with regards to x, is x times by 30 take 2x. And we can expand that. We've got 30x take 2x squared, and we can write it as a quadratic. Okay, minus 2x squared plus 30x. And so we've got a quadratic equation, and we've developed the equation. Okay, that was step 1, and now we're ready to find the optimal solution. So our value of a in this circumstance, that's the coefficient of x squared, minus 2. Our value of b is 30. C is 0. C is not involved in this formula. We don't need C. So let's put it in the formula. We've got minus 30 on 4. What are we going to have? 5.6, 7.25. Okay, so the optimal solution occurs when x is 7.25. All right, that's the optimal solution. But what does the question say? What is the optimal shape that generates the most area? So we've found the value of x, but let's state the dimensions, and then let's state the area that corresponds with those dimensions. So when x is 7.25, this length here is going to be 30, take 2 times 7.25. Now that should be 7.5, shouldn't it, not 7.25?
Yeah.
So we're going to have 30 take 2 times 7.5. I'm trying to work out what is this length. If this is 7.5, this is 7.5. This is going to be 15. Right, 2 times 7.5 is 15. 30 take 15 is 15. So the dimensions of this shape are 7.5 by 15. Okay, that's the dimensions that give us the maximum area. And so then what is the area? Therefore the area is going to be 7.5 times 15. 112.5. Alright? So you can see, we've got that process. First I drew a diagram. Alright, diagrams can help a lot, so if you need to, draw them. Then we've developed the equation. Then we've used this formula, okay, the axis of symmetry formula, x is minus b on 2a. We've found the optimal solution. This is the optimal solution. And then we've answered the problem in the context of the problem. We've put 7.5 into the function. We've found the dimensions. We've found the respective area. Excellent. Number 3. 1,200 metres of fencing is used to generate 6 identical pens. So let's see how we go here. 1, 2, 3, 4, 5, 6. That's pretty good. Where these lengths are x, and these lengths are y. Okay, explain why 12x plus 7y equals 1200. So we've got how many lengths of x? We've got 6 along the top here, 6 along the bottom here. We have 12 lengths of x plus 1, 2, 3, 4, 5, 6, 7 lengths of y adds to 1200 meters. All right, we've got 1200 meters in total. We've got 12 lengths of x and 7 lengths of y. Okay, that's part A. Part B, show that the area of each pen is given by this formula. Okay, so this is an example of a test question because they're giving you the formula. Remember, I've said we're going to do that. We're going to give you the formula, but so if you can't get that part, you still answer the parts later on. So how are we going to develop this equation? Well, what we need to do is we need to come up with an equation that describes the area of just one of these pens. Okay? So we've got the area is x times y at the moment. That's what we've got. And we've also got the expression that 12x plus 7y equals 1200. Okay, so we've got these two equations. This is the area. The area of this pen is just going to be x times y, and every single pen is like that because they've got the same dimensions. And then we've got this equation here that 12 lots of x plus 7 lots of y is going to be 1200 meters. We've got to synthesize them. We've got to bring them together. So over here, what we want to do is we want to come up with an equation for y in terms of x. All right, we want to express the area just in terms of x. So what I'm going to do here is I'm going to rearrange this to get y by itself. All right, so we can start. 7y is 1200. Take 12x. And then divide both sides by 7. Okay, so all we did there, we subtracted 12x from both sides. We divide both sides by 7, we've got an expression for y. Now what we're going to do is we're going to take this is y, and we're going to substitute it into our area formula. Area is x times y, therefore the area is going to be x times y, this whole thing. We've got an expression for x. Alright, 1200, take 12x, on top of 7. Which is 1200x, take 12x on top of 7, which is 1 on 7. I'm not sure where that 6 is coming from.
Take 12x,
That's squared, isn't it? So when we perform this multiplication, we've got 1200x, take 12x squared on 7. And then I'll just explain this step here. Rather than leaving it all on top of 7, I've pulled 1 on 7 out the front. Okay, that's a fraction, and we can leave that hanging out the front so that we can see it's a fraction times by this thing here. All right, now I have made a little bit of a blunder here because so in our book there it's not supposed to say 6 on 7, it should say 1 on top of 7, and I've already multiplied the x through as well. All right, but I'll show you how they're the same. X we can pull out the front there, so it's 1 on 7x. 1200 take 12x. Alright, here we've got 1200 take x. We don't need to multiply the x through. We need to make it look the same as it does on the piece of paper there. So we can leave the x out the front and just pull 1 on 7 out. I've made that longer than it needs to be. Anyway, the point of that is we've got the quadratic here. Okay, it's 1 on 7x, 1200 take 12x. So we've got the equation, we've shown that that's the equation. Now we're ready to apply the minus b on 2a. So I'm gonna actually fully expand it so we can see clearly the coefficients of a, b, and c. So if this is fully expanded, all right, what it's going to be is it's going to be 1200x on 7 take 12x squared on 7. All right. And we can even, let's just show you these fraction relations here. We've got 1200 on 7 times x, and and 12 on 7 x squared. Okay, so all of these are equal. They're just different ways of representing it. Now what's going to be most useful for us is this one here, because you can the one right at the bottom, because you can very clearly see what's the value of A, what's the value of B, ready for our x is minus b on 2a. Now remember, this is what we're trying to solve. X is minus b on 2a. So from this equation, A is always the coefficient of x squared. So I haven't written it in order there. Which one's the x squared term? This one, which means our value of A is minus 12 on 7, and our value of B is 1200 on 7. And we've got everything we need to put it in the formula. Let's put it in here. 1200 on 7 on 2 times minus 12 on 7. Okay, so we've got minus B on 2 times A. Okay, so nothing overly complex here, apart from perhaps these fraction operations. Let's revise them. We're going to have, I'm just going to expand this out a bit. So I'm going to put that negative, it can go to the top or the bottom, it doesn't matter. See? I'm just going to chuck it at the top. So I'm going to have minus 1200 at the top, on top of 7. And that's on top of, I'm going to multiply this 2 through now. So we're going to have 2 times minus 12, we're going to have minus 24 on top of 7. All right? So I've got 4 terms there. I've got A on B, on C, on D. Year 8 maths, we learned to divide fractions. So if we have A on B divided by C on D, it's going to simplify to AD on BC. Okay, that's a rule we should try and remember. All right, it's the top times the bottom. All right, AD on top of the product of the 2 middle ones, BC. So then down here, what this is going to become, it's going to be minus 1200 times 7 on top of minus 24 times 7. Okay? Now at that stage, you can just put the solution in your calculator, but we can simplify this a bit. All right, we've got 7 at the top and 7 at the bottom as a product, so they'll cancel. The negatives will cancel. We've got 1200 on 24, 50. Okay, so x is 50 is going to give us the optimal solution. So we've found the value of x. Last step, we need to answer it in the context of the problem. Find the optimal solution. Well, the optimal solution occurs when x is 50. So what are the dimensions going to be then? It's going to be 50 by y, 50 times y. What is the value of y? Here's our equation for y. Okay, so we need to say, well, given x is 50, what is the value of y? So therefore, y is going to be 1200, take 12 times 50, divided by 7. So what's that? 60, 600 on 7. 600 on 7. What's that as a decimal? $85.7. Okay, so our optimal solution then to answer this problem, I'm going to answer it here. The dimensions that provide the maximum area are 50 by 85.7. Alright, so yeah, that is a long one. It's a long one. Got a scaffolded for you. And it's just following those same 3 steps. Okay, first we drew a diagram and we had to construct the equation. And I've said that's the hard part. Okay, because here we had to say, oh well, the area is x times y, and then here we've got an expression for y, and let's substitute that in there. So then we have this area function. We fully expanded that out so we can identify our values of a and b. And then we put it in that x is minus b on 2a form. So always the same process, all right? And so even if you're not able to do this part, to bring those two together, it still gives you the formula. So that means you can still answer this part. Right, so you're not limited by not being able to answer part C because you've got the formula that you need to do it. Okay, so this is H, optimization. Let's give it a go.